Okay guys, I'm going to help you out with lesson 10's homework, and let's go ahead and start off with number 1. It says shade the parts in the area models below, decomposing tenths as needed to represent the pairs of decimal numbers. Fill in the blanks with greater than, less than, or equal to compare the decimal numbers. So in the first one we have 0.19 and 0.3. So I'm going to shade in 0.19, which would be 1/10, and then 900ths. So you're going to have to split that second tenth into 10 pieces unless you want to separate the whole thing. And then I'm only going to shade in 9 of those to represent 1/10 and 900ths. Okay, on the next one, it's 0.3, which would just be 3/10. So even though 0.19 looks bigger because it looks like 19 and the other one looks like 3, really 0.19 only has 1/10, 0.3 has 3, so if you can just tell by the picture, 0.3 is going to be larger. Okay, on part B, we have 0.6 and 0.06. So this is going to be 6/10. And the other one's going to be only 600, so you have to split that first tenth into tenths for hundredths. You're only going to shade in 6. So even though they both have a 6 in it, the 6/10 is going to be larger because it's different from 600ths. Okay, the third one says 1.8 and 1.53. Well, they both have a whole, so I'm going to ignore that, and I'm just going to compare the decimals. I'm going to go to the next place over, which is the tenths. Well, 1.8, I'm going to shade in 8/10. We're going to pretend like we already shaded in the whole. I'm going to shade in 1, 2, 3, 4, 5, 6, 7, 8. And the other one is 0.53. That doesn't mean 53/10, it means 5/10 and 3/100. So once we get those hundreds shaded in, it's clear that the 8/10 is going to be bigger. Even though 8 looks less than 53, that's not the same thing. It's 8/10 versus 53/100. You know, 8/10 is the same as 80/100, which is going to be bigger than 53/100. Okay, 0.38 compared to 0.7. Again, 38 looks bigger than 7, but this really means 3/10 and 8/100, which I'm going to shade in here. And 0.7 means 7/10, so it's going to take up a lot more of that whole, which is going to make 0.38 less than 0.7. Okay, on number 2 it says locate and label the points for each of the decimal numbers on the number line. So you have 7.2 compared to 7.02. So basically we're just doing the same thing, but we're comparing them on another number line. Well, if I look for 7.2 on the number line, it's right here. And 7.02 would be 200ths, which would technically be between 7 and 7.1, and it would be 2 spaces over if that's the hundredths. So really, 7.02 is less than 7.2. So I'm going to say 7.2 is greater than 7.02. All right, let's look at B. It says 18.19 compared to 18.3. Well, 19 looks bigger than 3, but when you really plot it, 18.19 is actually going to be one space before 18.2 because it's 1/10 and 900ths, and 18.3 is going to be all the way down here. So that means that 18.3 is going to be bigger. Okay, on number 3, we're just going to compare, and you can use whatever method you want. I'm just going to compare using place value. So on A, they both have 2 wholes, so I'm going to ignore that. So it's just like when you compare other numbers, you keep going till you find one that differs. So they both have 2 wholes, so I'm going to cross those out. The next thing I look at is the tenths. Well, the first one has 6/10 and the second one only has 5, so that makes this one bigger. Part B, again, if I compare the wholes, they both have 6 wholes, so I'm going to move over to the next place value. The first one has 3, the second one has 7, so that one, the one with the 7 is going to be larger. Here, I don't even have to compare the decimals because this has 9 wholes and that has 7 wholes, which automatically makes 9.28 bigger. 3.02 and 3.2. Well, they both have 3s. When I look at the tenths, the second one has 2/10 and the first one has 0. So that's going to make 3.2 larger. Same thing here, 13. Can't compare that. Well, the first one has 1/10, the second one has 1/10. So they're basically the same thing. They both have 0/100, so that's actually going to make them equal. And then on F, 5.8 and 5.92, fives cancel out. I mean, they don't cancel out, but you know that they're the same. And if I compare, the second one has 9/10, the first one has 8, so that makes 5.92 larger. Okay, on the last part, you can use pictures or whatever you want. I'm again just going to compare the place values after I write it. 57/10 is the same thing as saying 57/10, so I can kind of conceptualize this better. Which really, when I write 5.7 as a fraction, it's 5 7/10, which is the same thing as 57/10 as a fraction greater than 1, so really these are equal. On the second one, 6.2 compared to 6 ones and 200ths. Well, 6 1 and 200 is 6.02, and we know that the first one has 2/10 and the second one has no tenths, so that's going to be larger. Part C says 33/10 and 33/100ths. Well, 33/10 would look like 0.33. I'm sorry, not 0.33. 33/10 would be like 33/10, which would really be 3.3 because it's 3 wholes and 3/10 left over. And then 33/100ths would really be like 0.33. So automatically 33/10 is larger because it has 3 wholes. Okay, part D says 8.39 and 8 39/10. Well, 8.39 is 8 39/100ths, but 8 39/10, 39/10 is more than a whole. 39/10 would be like 3 9 wholes, or 9/10 that you're going to add to the 8, which is automatically going to make 8 39/10 more than 8 because you have all those extra wholes to add. So it's going to be 8.39 is less than 8 39/10. Okay, on part E, we have 236 hundredths, and I can't see this bottom part right now. It actually says 236 hundredths and 2.36. Sorry, guys. Well, 2 36 hundredths is going to be the same thing as I could pull out 2 wholes and have 36 hundredths left over, so that would be 2.36, so those are going to be equal. The last one is 3/10 and 22 hundredths. Well, 22 hundredths only has 2/10, so that's going to make 3/10 larger. Let me know if you have questions.